Welcome to another incredible edition of Comet Algebra. This video is for Algebra 1, Chapter 12, Section 2, Solving Quadratic Equations by Taking Roots. So we continue learning how to solve quadratic equations because they're going to come in different forms. But first we're going to compare how we solved this equation back in Section 1. In Section 1, we took this x squared, subtracted a 64 from both sides, and then we factored it. After setting both factors equal to 0, we came to the conclusion that the answers are plus and minus 8. Well, there is another way to look at this quadratic equations, and the ones that do not have an x term. In other words, they just have the x squared term and they have a number. When we have that, this is really, really handy, especially when they don't factor. So this is super useful and it's very easy. So I want you to look and recognize when to use it. And the key is when there is no x term in the quadratic. So the steps are, one, first you isolate the x squared. You get it all by itself. No numbers being added or subtracted to it, and no numbers multiplied. You just get the x squared. And then you do the inverse operation. You take the square root of both sides, and then like we learned in Chapter 11, we simplify the radical. So let's do this equation again, but let's use this other method this time. So step 1 says isolate the x squared. So we want to get this x squared all by itself. So the first step we do is add a 64 to both sides. Step 2 says take the square root of both sides. So I take the square root of x squared and the square root of 64. When you take any number x and you square it and you square root it, those two operations undo each other and we are just left with x. Now here is where there's a little bit of inconsistency with the way they wrote this textbook. In Chapter 11, when you did the square root of 64, they had you taking the positive root of it. But in reality, the square root of 64 does have two answers because 8 times 8 is 64, and also negative 8 times negative 8 is 64. So when you are solving a quadratic, the 2 here tells us we're looking for two answers. In this situation, we need to include both roots of 64, and once again, the answers would be plus and minus 8. You also need to understand that there are 3 different possibilities that can happen when you do that step of taking the square root of both sides, depending on what ends up under the radical. When the number under the radical is positive, let's say it's just 10, and you end up with your answers then being plus and minus the square root of 10. In radical form, that's fine. The second possibility that could come up is if you end up with the square root of 0, because 0 isn't positive or negative. The square root of 0 is just 0. So that doesn't happen real often, but when it does, there's one answer. And then going back to some information we learned in Chapter 11, if you took the square root of both sides and you end up with a negative number under your radical, this does not exist in real numbers. We will learn about this in Algebra 2. This would be an imaginary number, but right now, when you have a negative under your radical, there are no real answers. So keeping those 3 possibilities in mind, what could happen, and following the steps, let's do some examples. So in example 1, the x squared is not isolated, so we need to start by dividing by 2 on both sides. Then we would get x squared equals 10, and now we would take the square root of both sides. So x ends up being plus minus square root 10. I always check under the radical. 10 is just 2 times 5, so there's no perfect squares hiding in 10. There's nothing to simplify. So leaving my answer in radical form, it's plus minus square root 10. Looking at example 2, we have a couple things to do in order to isolate the x squared. First, let's add a 2 to both sides. So we get 5x squared equals 405. Then I need to divide both sides by 5. And if I divided that correctly, I got 81. Next, take the square root of both sides. And again, remembering we need both the positive root and the negative root of 81. So in this case, my answers are plus minus 9. In example 3, again, I have a couple steps to isolate the x squared. So we'll start by subtracting a 14 from both sides. Then we will divide both sides by 2. And then square root both sides. And we have a problem. We end up with x being the square root of a negative number. This is not existing in the realm of real numbers. I don't want you to say that there is no answer at all, because there is an imaginary answer, and we'll learn about that later. But there is no real solution. So the key is that it's not a real number. Looking at example 4, just to refresh a few things, again, there is no x term. We just have an x squared and some numbers. So that's when you know you're going to use the approach of taking the roots of both sides. But now we have to think back to all the skills we've learned. I think this was back in chapter 2. When you have your variable on both sides of the equation, you need to get it together on one side. So first step could be subtracting a 5x squared from both sides. And 6x squared take away 5x squared is just x squared. And now I'm going to, again, I have to think about isolating the x squared. So we're going to add a 22 to both sides. And we get x squared equals 40. Now we want to take the square root of both sides. And remember, it is both the plus and the minus square root of 40. And here's where you stop and take a look at your answer. Can this radical be simplified? Well, 40 is, obviously there's a 4 in it. That's why I wanted you to be able to recognize perfect squares. The 4 is the perfect square. And if you did the factor tree, sometimes I just do this because I see the perfect square. But we would get the same thing if we did the full factor tree and looked at all the prime factors. Pairs are squares, so the perfect square of 4 is 2. The 2 would come and be out in front, and we're left with 2 times 5 under the radical. So the simplified form of the answers, plus minus 2 square root 10. All right, now you have the knowledge you need to do section 2 in chapter 12, so have a fabulous time with that math.